Hi guys, it's Miss Ruby again. So I realized we need to talk a little bit about ions in case, make sure everybody understands what's going on here and how to appropriately name ions. Okay, so this should not take too long. I hope I don't go off on a spiel, but let me go ahead and go to my handy dandy whiteboard. Oops, wrong thing. Hold on, guys, hold on. Okay, there we go. Okay, so yeah, let's just look a little bit. I did this with my class last year for the first time, and I was really glad that I did it. And we took a moment to look at naming ions, okay? And like I said, I was happy that I did this because it provoked questions, and that meant learning was happening, okay? So let's talk about cations first. And since we don't have a lot of room, I'll leave it to cations first, and then we'll do anions, but I'm going to use the space for cations. It's real easy, though. You simply write the name of the element, name of element. That's it, right? Hold on, so Mr. Murphy needs to go. That's not quite it. So if it's a single charge, I'm thinking of a better way to do this. I'm going to write the name of the element, okay? Then I'm going to think to myself, if the cation has multiple charges, what do I mean by that? For example, +1, +2, +3, +4, etc. Okay? Then the charge, I'm going to write this out a little bit more than I normally would. Then the charge, what's the best way to say this? Then the charge on the cation presently, the present charge must be denoted. It must be represented. And I'm going to try to explain, example this must be denoted. By denoted, it must be present. It must be a part of this, okay? So it's really simple. I'm going to write this in a different way, okay? I'm going to write this such that we have single charge cations, and we have multiple, I should have started with this, charge cations, okay? And what we see is that this is our cations that always have the same charge, right? Sorry, I like to write things out for those of you that like to write it. Those are cations that always have the same charge. These are cations that have different charges at different times. Okay, so sometimes they're playing with a +1 charge. Sometimes they're playing with a +2 charge. Sometimes it's +3, etc. Okay, so with a single charge, okay, there's only one charge involved. Multiple charge, okay, the charge changes. All right, so if you look at your periodic table, this is just a rough, a rough drawing. We know that everyone right here is a 1+ ion or alkali metals. These are single charge. right? They're always +1. These are 2+. They're always 2+. Sorry, I'm getting messy on you guys. These are 2+. They're always 2+, right? Our alkaline earth metals are always lose 2 electrons. So these are single charge as well. All right. Now, what you should start be realizing, right? There's a little stair step here, which separates our metals from our non-metals. And that most of these, let me get a different color here, guys. Most of these here, right? These are no longer metals, right? These are non-metals. But most of these, are multiple charge. Now, I unfortunately do not have a periodic table sitting in front of me. Oops, which is unfortunate. And my brother's calling. Let me turn that off. Most are multiple charge, right? I'm going to give you an exception. Like aluminum is somewhere like right here. Aluminum is always a 3. Another exception is zinc. He's always a 2. Silver, always a 1. All right. I do not have my periodic table here, but I think cadmium around here is always a 2, right? The problems with not being in my classroom, I don't know. But these here are considered single charge, single charge, single charge. You really need to realize silver and zinc and aluminum. Okay. And I'm sorry, I can't elaborate on that right now. I just got extremely distracted by that phone call. Okay, so we're just looking at naming ions. Keep it simple, Miss Murphy. Naming ions. Monatomic. Right? Single charge. Monatomic was non-necessary. Element, name, plus the word ion. Okay, I'm going to start cruising along here. Right? If I want to name this, it is the sodium ion. If I want to name this calcium 2+, it is the calcium ion. Okay. Lastly, if I want to name this silver, it is the silver ion. Aluminum is the aluminum ion. Okay, so you're like, okay, so what's going on? Well, that was if it was single charge. Okay, what if it was a multiple charge cation? Well, that's easy, right? Copper +1. I'm going to write 1+ because that's actually correct. Copper 2+. This is my copper 1 ion. Denote charge, right? We said denote, oops, hold on guys. Denote charge. We said denote means to tell, to inform. Denote charge with Roman numeral. Okay, so what I've done here is I've used a Roman numeral. Excuse me, right here I use the Roman numeral 1 because my charge over here is a 1. So down here, since my charge is a 2, I will use a Roman numeral of 2. And I will call this the copper 2 ion. Now there is no copper 3 ion, but you can imagine what it would look like, right? Okay. Now, if we finish this, all right, let's look at our anions. All right, let's look at our anions. They can be polyatomic. I probably should write this other word first. Monatomic or they can be polyatomic. Okay, what you need to recall is that this word right here means that they are negative, and they will be found at the end of the compound. Okay, so typically you're going to recognize that a negative anion is monatomic because it's going to end in "ide." All right, IDE. There are exceptions. Oh, let's go here. Okay, I'll show you this. Polyatomic ions, you're going to recognize them because they're going to end in ite, ITE, or ate, ATE. Okay, if you look at your polyatomic ion chart, you will see that most all of them end in ite or ate. There are a couple of exceptions. All right, you need to be aware of those. You've got hydroxide. All right, hydroxide ends in IDE, but it is not monatomic. All right, it's actually an O and an H bonded together with a negative charge, so it's polyatomic. You just have to memorize it. Okay, there is cyanide. You're not going to see this very often, but it ends in an IDE. It is not monatomic. It's polyatomic. There is peroxide. All right, that's going to be O2, 2 negative. This is more than one atom. This is not monatomic. It's polyatomic. And then lastly, there's ammonium. Okay, you will see ammonium. You will also see peroxide. Ammonium is our only positive cation. So it will be in the beginning and not the end because the positive comes before the negative. All right, let's just put this into practice and then we'll be done here. Once again, anions, you've got to look at the ending, and the ending tells you what type of anion you might be dealing with here, okay? If whether it's monatomic or polyatomic. Okay, so look at this. I'm going to see phosphide, all right? And I go, oh, look, that's ide. So they must be referencing, remember, I'm only talking about ions here, okay? And this pertains to ionic compounds. All right, so I just realized in my brain something you could be confused about, but we're talking about when these guys are ions. So I see ide and I think, okay, monatomic. And then I'm like, okay, so I'm just going to use the front, right? This is a single element front. What do I mean? If I was in class, we would be talking about the front of the periodic table, and we would be talking about the back of the periodic table. Okay, so we just need the front. All right, so that's phosphorus. And based on his location, we know that he is going to carry 3 extra electrons, so he'll have the 3 negatives. All right, let's put let's put phosphate with that, right? Well, now I see that the ending, remember I said it's all about the ending, because it ends in ATE, this is polyatomic. So I know that this is a fancy little guy, right? So I'm going to look on my chart, and you're going to start remembering chart, right? You're going to look at your polyatomic ion chart, because the 8, as opposed to the ide, tells you this is polyatomic, and we see that this guy is actually PO4, 3 negative. Let's come over here. Let's write phosphite, right? Ion. And you say, okay, look at the ending. It's ite. This must be polyatomic because it's not ide, right? We look on our chart and we see that this is PO3 with a 3 negative charge. Okay, I'm going to do a few more. Right, I'm just going to do a few more. I see perchlorate, and I see this 8, and I think polyatomic. I look on my chart, and I see ClO4 with a negative charge. I could also see chloride. Well, that "ide" tells me that this is monatomic. So I need to use the front. This is a single element with a charge. This is chloride. I could have chlorate, not to be confused with chloride. And this 8 tells me that it's polyatomic, right? So I'll look on my chart and I see ClO3 negative. Almost finished here. I could see chlorite, polyatomic, right? So I'm going to look at my chart and I'm going to see ClO2 negative. Let's take this one step further. I could see hypochlorite, right? It ends in an "ite." It's poly. I look on my chart. I see that it's ClO negative. All right, I can't help but to take this opportunity to show you how this works. I've got a Per8, has 4 oxygens, the most oxygens, all right? I've got an 8 that has 1 less oxygen, right? I've got an ite that has even 1 less oxygen. And then I've got a hypoite, which means another less oxygen, if that makes sense. 2 less oxygens, 2 less oxygens, okay? No, I don't like that. I'm going to write another less oxygen because you don't know what it's 2 less from, right? It's less from the ite. So it always goes Per8, 8, ite, hypoite, okay? Another less oxygen. And I'm going to give one more example of that, and then Miss Murphy's going to sign off. So you would see that with your bromates, right? I'm going to start backwards. I could, no, I'm not. I could say per bromate, that's BrO4 negative. I could get rid of the per and write bromate, that's BrO3 negative. I could have 1 less oxygen, and then my 8 turns into an ite, and that's BrO2 negative. Or I could have even another less oxygen, and then I get the prefix hypobromite, and that's BrO negative. Now, signing off, what's bromide? Ide here means it's not poly, it's just bromine as an ion. Okay? Don't forget ammonium. Don't forget hydroxide. And don't forget peroxide. Okay? I'll be sure to bring those up in the other videos. This one's been long enough. So I am going to say bye. You might have some questions. We'll talk about it. Bye.